All right, let us begin this great reviewing adventure together. In an unusual year, we're going to do a fair amount of videos. I don't plan on doing a video every day necessarily. What I kind of want to do is we'll start back at the beginning with chapter one and data displays and graphs and numerical measures, and then we'll spend a couple days practicing some problems that are tied specifically to that. And kind of work our way through. And then the last few weeks before the AP exam, then we'll look at some problems where a lot of topics are mixed together in a single question. Because that's what you're going to see. You guys are going to see two problems this year, and they'll probably touch on a number of ideas since they have to get all of their grading just from those two problems. But let's start with chapter one, which is data displays and describing data. You need to know the difference between the two main kinds of variables. We have categorical variables, which is when you're using your variables for sorting into different groups. So this could be something like color, or it could be maybe gender or something like that. Quantitative is always numerical. And with numerical variables, that means you can take that data and calculate the mean, the standard deviation, quartiles, things like that. Just remember that it's really about what you're using it for. You can have categorical variables that are numbers. There are times where age is being used as a categorical variable, um, depending on what you're working with. So it's really about how is the data being used in whatever situation. All right, if you are given a set of data, you should be able to describe it numerically, which means you need to be able to find the mean, the standard deviation, the range, the IQR, and the 5-number summary. The 5-number summary is min, Q1, median, Q3, and max. If you were to pull up your calculator and you had a set of numbers in here under stat edit, and you wanted to find the numerical summary and some of these values for them, that is where we do stat calc 1var stats. If yours pops into this menu, if you're just putting in a single list of numbers, this is exactly how it should look. That frequency list we're going to leave blank unless we're doing those probability distributions, which here we're not. If yours does not pop into this list, you're just going to do stat calc. It'll pop in 1var stats. Then you'll do second 1 so that it says 1var stats and then L1. But for me, I just need to go down to calculate. So X bar is the mean of that list of numbers. Technically, sigma is the total if you added them all up, but we don't do too much with that. We always want to use SX. We will never use sigma X, except for that one weird case where SX is blank. But SX would be our standard deviation. It does give you N, which is the number of numbers in your list. And then there is our 5-number summary, the min, Q1, median, Q3, and max. You need to be able to describe a set of data graphically. So the kinds of graphs you should be ready to make are a dot plot, a stem plot. A frequency histogram and a relative frequency histogram are essentially the same thing. Relative frequency just means you're dealing with percents. If you are going to make one, you can just make a frequency histogram. You need to be able to make a box plot with outliers. You need to be able to make a bar graph, a pie chart, and a segmented bar graph. The segmented bar graph is the one that we haven't seen necessarily as often. The other one we need to add to this list, these are old notes, but I kind of forgot we added this in, is and probably not, you wouldn't have to make it, but we also had the mosaic plot. The thing that's tricky is, realistically, if you're going to make a graph, it's probably going to be something relatively simple, maybe a couple of box plots that you're comparing. Maybe they'd have you make a dot plot or a stem plot. More than likely, they would just give you the graph and ask you to describe it, which we'll get to in a second. But these are the different types of graphs we've dealt with. The ogive for percentiles we'll talk about on the next page. You also need to be able to describe graphs. If they ask you to describe a graph or describe a set of data, there are different acronyms out there, but CUS is what we used if you're dealing with any sort of a quantitative graph. So a dot plot, a histogram, a stem plot, we're going to use CUS to describe the shape, and we'll look at a couple of those in a second. If you have some sort of categorical graph, like a bar graph or a pie chart or a segmented bar graph, then you're just writing observations that you notice. There isn't really a set acronym or a set list of things for those kinds of graphs. You kind of just got to look at what's there, and usually you're making some comparisons among sets of data. If they ask you to compare, particularly for quantitative graphs, and most often on the AP test, they give you a couple of box plots, but it could be a couple of stem plots. When you compare, you should for sure talk about center, shape, and spread. So 3 of the 4 for cos, but if they ask you to compare, make sure you are actually comparing. So comparing means you're saying things like larger than, smaller than, higher, lower, saying the same as a comparison. The trap that people fall into is they will say things like the median of this graph is 54 while the median of this graph is 17. While is not a comparison. To be a true comparison, you need to do larger or smaller, greater than, less than, as same as, something like that. If you saw an ogive, and to be honest, I think this is a relatively low likelihood with only 2 questions, but if you did, the idea with an ogive is either you are tracing up from the x-axis until you hit the graph, then you trace over to the percentile that matches up with it. So if we wanted the score that corresponds to the 90th percentile, I would trace over from 90% until I hit the graph. And in this case, I would hit the graph right about there. And then I would want to trace down from that spot. And my axes aren't super detailed, but it looks like this would be right around 51. In the second question, it says another student got a 32. So now you're starting with the score. We would start at that score. We would trace up until we hit the graph. Then we would trace over from that spot until we hit the y-axis. And then we would write our percentage. So for this, again, we're kind of eyeballing a little bit, but somewhere around 21, 22, 23%. The only way they could get tricky is instead of giving you the flat out numbers, if they asked about some value by name. So the center of a distribution is the 50th percentile. So I would trace over from 50 till I hit the graph. I would trace down from wherever I hit the graph, and then that would be my value. So here, center would be approximately 41, which is the median. They could also do the IQR. So then you would trace over from 75th percentile and 25th percentile, and you would just subtract those 2 answers. So again, not super likely you'll see an ogive, but that's how it would work. All right, way more likely for you to see is to ask you to describe a display of univariate data. Univariate just means single variable. And we use the acronym CUS. If they say to describe, that's really a loaded question. We should be talking about 4 things. We should talk about the center, which if you have the data and you can type it in your calculator, just find the median exactly. Now, if you don't have the data, or if it's like this is a lot of data points for you to have to type in, it is okay to eyeball it. If they're just asking you to describe without asking for any more specific measurements, it is fine to just kind of eyeball and say that the center is around 39. U is for unusual points, so any extreme observations would work. The main one we're looking for is outliers. But if there are other unusual features or unusual points, or if there's a cluster of points, maybe there's too many points, like let's say there was 10 points here. That's probably too much to say we have 10 outliers, but we might point out, oh, there appears to be a cluster in the 20 to 25 range. Not here, but if that was in the graph. So U is for unusual points, generally we're looking at outliers. Shape, generally the 3 most common we're going to see are skew left, skew right, or symmetric. But if you had other things going on, bimodal means that it has 2 peaks. Uniform would mean that all of your data bars or stacks of points are the same height. Somehow you're describing the shape that you see. And then spread, there's been debate in the past about what's the more relevant value to give. Should we give the min and the max? Or should we give the range, which is max minus min? My advice is to give them both. So if they ask, when you're describing, I would say your spread is from whatever your min is to your maxes. So the spread is from 2 to 50, a range of, and then do the subtraction to get the actual range. 50 minus 2 would be 48. So looking at just 3 for quick practice here. For this graph, I would say the center is around 39. I'm just kind of eyeballing that, but that's roughly where it seems. If you were relatively close, that would be fine. For this particular one, I would say there are no unusual points. These ones are kind of drifting out here, but they're not so far away. Um, this shape on this one is, to be honest, is really tough. I think if you said it's roughly symmetric, you could even say roughly symmetric except for a couple points, that would be okay. I think maybe slightly skew left. If our center's here, it is fading a little bit more. There's a little bit more of a tail this way. But this is a tough one. They would not split hairs with you on that, I don't think. The spread is from 26 to 47, which is a range of 21. I'm just subtracting those two. The one in the middle, the center is around 2. Again, I'm kind of eyeballing a little bit. You could actually count the points if you wanted to give the exact median. I would say in this one, 20 and 24 outliers. You could maybe debate these and say they're mild outliers. I don't know, but 20 and 24, are definitely way far away from the rest of the data. This shape is definitely skew right. There's not a lot of debate here. Again, if you're thinking about skew right versus left, the direction of the skew is always where the thin part of the tail is. Or if you like the skiing analogy, pretend you're at the top of this hill and you're going to ski one way or the other. The skew is whichever one gives you the nicer, smoother ski run, which definitely is to the right here. If you try and ski off the left, it's not so much a ski slope as it is a jump. And then in this case, the spread is from 1 to 24, which would be a range of 23. And then the last one here, the center for this one I said is around 75. Because it's skew left, the center is probably not at the peak. It's probably a little bit to the left. 60, I said, was a mild outlier. This 81, there's a little bit of a gap here, but not so much that I would say it's an outlier. Shape is definitely skew left. This time you could ski to the right, but that's like the double leg diamond. We want the smoother ski run to the left there. Or the real version, the tail is longer on the left, which is why it's skew left. And then the spread is from 60 to 81, which is a range of 21 if you subtract them. Okay, so in general, when you're talking measures of center versus measures of spread, if they ask for the mean is just the average value. It's X bar on your calculator. You just add them all up and divide by the number of things. The median is the center value. It's the 50th percentile. It's exactly halfway from the lowest point to the highest point. When your data list is in order, median and Q2 are the same thing. Q1 is the first quartile, which is 25, so first quarter, 25% of the way from the min to the max. It technically is also the median of the lower half of the data. So it's the half of the lower half, and Q3 is the half of the upper half. It is the third quartile. It is 75% away from the min to the max. And some people it bothers them maybe a little bit to call the quartiles measures of center, but it is the center of the lower half, the center of the upper half. That's why they get lumped in there. Our measures of spread are interquartile range. And this one you have to do manually. You can do one of our stats to get the quartiles, but you have to manually subtract them to get the actual value for the interquartile range. Range, which is max minus min, that's another one that you have to do manually. Just do the one of our stats and take the max minus the min. And then standard deviation is SX on your calculator. I talked about that when I pulled that up a minute ago. If you were asked to interpret it or explain it, we would say it's roughly the average distance from each point to the mean. So, one of the very common questions, now it's very common on multiple choice. Again, this year, I don't know exactly what you might see, but if you're ever given dot plots and you just want to, just by eyeballing, say which one has the largest or the smallest standard deviation, we're looking at where the mean would be. All three of these are roughly symmetric. Two of them are exactly symmetric. One's just close. And standard deviation is roughly the average distance from each point to the mean. So the largest standard deviation of these three is going to be the one that has the most points pushed furthest from the middle, because that's where the mean would be. So in this case, B would have the largest standard deviation. It has most of its points pushed out near the edges, which is farther away from the mean. C would have the smallest. It has the most points right on top of the mean. And then A would be somewhere in between. If you are transforming data, so if you ever have an entire list of numbers and you're going to manipulate that list, the most common thing is either maybe to add or subtract a value. If your measurement tool was off, like maybe you're using a scale and you realize, oh my gosh, this was off by 2 grams. We forgot to zero out the balance. Or you're measuring with like a ruler and you realize that the end is broken off and it actually was missing an inch or something like that. Or if you are converting um, from one unit of measurement to another. Anytime you add a constant to an entire list of numbers, that is going to add or subtract. It could be a negative constant. But adding a constant to an entire list of numbers adds a to all the measures of center and to the quartiles and all the other measures of location. Min and max would get added or subtracted that same number too. But it does not change the measures of spread. If I have to add 2 to every weight that I measured using a balance because it was off by 2 grams, the measures of location would change, but the measures of spread do not. Another visual I like to think of this is if you had a dot plot in a graph, adding or subtracting a number is like picking up all the dots and sliding them to the right or sliding them to the left on the number line. It'll change where they are, it changes those measures of center location, but the points aren't going to be any more or less spread out if you're moving them all the entire same distance. If, on the other hand, you are multiplying an entire list of numbers by some constant, so if I multiplied every number in a list by 7 or every number in a list by 4, that multiplies the measures of center and the measures of spread. This is essentially when you're scaling things, if you're converting units, everything gets multiplied here, both measures of center and measures of spread. All right, last thing that you might see is dealing with outliers. This is one that I pulled from an actual AP problem. I think it's less likely that they ask you about outliers for a set of data where they give you all the numbers. Because one of the things you can do, in fact, let's do this on the calculator quick. Let's go back to that same list of numbers, and let's say I wanted to make a box plot, and I want to make a box plot that shows outliers if there are any. I would go to second, and then y equals. I'm going into the graph. I want to always never choose this box plot. I always want to choose this one that shows the outliers if there are any. Hit enter. And my numbers are in list 1. Everything's squared away here, so I'm going to quit out of here, and then I am going to zoom 9 so those numbers show up. This graph, this set of data does not have any outliers. If there were any, it would show it on the graph. If you had to make a graph from this, if you hit the trace button, it'll actually show you it'll pop on one of the values here. It popped on the min. And now you can arrow left or right to find those other 5 numbers, the quartiles, the median, and the max. And then you could just draw in your scale underneath. In this case, are there any outliers in the data? Often they have tested like this where they don't give you the raw data, so you actually have to know a way to measure outliers. So the first thing we need to do is find the IQR. They give you the quartiles, and IQR is Q3 minus Q1, so if you take 19.25 minus 9.68, that's IQR. And then there are boundaries for outliers, at least the way our calculator does it, which is the way we did it in class, just so those two match up, is to take Q1 minus 1.5 times IQR, and then take Q3 and add 1.5 times IQR. The 1.5 is always 1.5. It never changes to another constant. The reason why just goes back to when they were first doing a lot of number crunching and making some of these like rules of thumb and general guidelines. 1.5 was the value that was simplest, that best matched what they were seeing in the data. So it's always 1.5, but that's kind of why. So here I want to take I'll start with Q3, and I'm going to add 1.5 times that 9.57 times that IQR, and I get the number 33.61. I'm also going to take and subtract Q1, not Q3 this time, Q1 minus 1.5 IQR, so 9.68 minus the 1.5 times 9.57, that gives me negative 4.68. Now right now these numbers are meaningless. We need to explain what the heck those show us. So I think the simplest way to say it is anything greater than 33.61 or less than negative 4.68 is an outlier. Now we don't have the actual data, so we won't know everything, but they did give you the min and the max. So all we have to do is look at the min. The lowest value in this set of numbers is 4.85, and that is not lower than this kind of lower boundary value. So there are not any outliers on the low end. Our max, though, we have at least one data point that goes as high as 38.18, which is larger than 33.61. So then what we would say to conclude that part of things is to say there's at least one outlier on the high end since the max is larger than 33.61. What we don't know is there multiple? There could be a 37.2 that's also in this data set, which we can't tell from here because it's not bigger than the max. So all we can say is there's at least one outlier at that maximum. Another thing that they'll do from time to time, and it actually throws people off, it's not a hard question, but they'll just ask you something like this. The news media reported that in a particular year, there were only 10 inches of rainfall. Use the information provided to comment on this reported statement. They're not necessarily looking for any specific, like, oh, you have to have this particular answer. They just want you to comment. Look at these values, and what kinds of things could you say about a data point of 10? Okay, so then just start looking at the values they give you. Well, 10, where is 10? 10 is below the mean and below the median, so that would be a lower year. It's not lower than Q1, so it's still in that middle 50% range, so it's not particularly unusual. It's definitely not an outlier. And just write a few statements about this. So this is just one example. You could say 10 falls between Q1 and the median, which means it falls between the 25th and 50th percentile. 10 is also lower than the mean, which means it's below average, but not particularly unusual since at least 25% of years had less rain. And that 25% just comes from Q1. So again, there's lots of ways you could phrase this. You could also talk about standard deviations. You could say that since the rain falls within one standard deviation of the mean, standard deviation here is 6.7 and the mean was 14, that the 10 is not an unusual year of rainfall. They took lots of different things. In a question like this, they just want to see if you can put your own words behind, hey, what would you know about this data point of 10? So just one example, but I just wanted you to at least have seen one kind of question like that. And that pretty much wraps up things for this first chunk of notes. So now we'll spend some time practicing some of these kinds of problems. But if you have any questions, please let me know.